Right, so in this video I'm going to go over the squeeze theorem. I'm going to have 4 questions and 4 answers, and I'm going to work through them basically just to see how to solve each one. A little bit of theory on the squeeze theorem first. If you have a function f of x which you can't evaluate at a point, so that's if it's 0, if it's infinite, if it's minus infinite, or you just can't evaluate it because it will be divided by 0, this is when you use the squeeze theorem. So if you have a function higher than f of x and a function just lower than f of x, and the limit equals the same thing as it approaches the same thing, then you can say that the f of x also approaches the same limit. So we're going to go over a few questions here. The first question is the limit of x as it approaches 0, and the function we've got for f of x is x squared times cosine of 1 over x squared. Now obviously you can't just plug in 0 here because you have cosine 1 over 0 which is not defined. So to solve this, what we need to do is first evaluate cosine. Now we know cosine can be bounded between 1 and minus 1. So if we write cosine in the middle, 1 over x squared, bit dodgy x squared there, but we know that this can be evaluated between 1 and minus 1. So this is similar to what we're dealing with originally here. However, it's just missing an x squared. So if we times it by x squared, if I get my other pen, if we times it by x squared, we're essentially getting x squared on the left, and then the original function back in the middle, so x squared cosine 1 over x squared, and this on the left side is just minus x squared. Now if we follow this step here, we take the limits of this side and the limits of that side and evaluate it as x tends to 0, which you can do because that is defined. So we're going to evaluate the limit here as x tends to 0 of minus x squared. Now obviously that's just equal to 0. Now if we do the same from this side here, we get the limit of x as it tends to 0 for this x squared is also equal to 0. And by this, I'll call this part 3 and pause part 2. And by part 3 we can say that because the limits are the same, that means that this f of x also has to equal 0. Okay, so the next question we've got is, they're taking the limit of x tends to infinity, and we've got x squared all times by 2 plus sine squared x over x plus 100. Now, if we do the same thing as before, we take out a trigonometric function. So we're going to take this out and evaluate it. We're just going to evaluate sine for now, because like before, we know that sine of x can only be bounded between 1 and minus 1. However, we've got sine squared, so we can just simply say that sine squared can only obviously be evaluated between 1 and 0, because a squared value can't take a negative value, so the lowest value it could be is 0. Now here we're missing a plus 2, so we're going to add plus 2 to each side. So we've got on this side 3 and then 2 plus sine squared x, and then on the left side we've got just 2. Okay, so now we've nearly got the top part, we're just missing the x squared, so we're going to times everything by x squared. So now on the right side we're going to have 3x squared, on the left side we're going to have 2x squared, and in the middle we're going to have x squared all times by 2 plus sine squared x. So now we've got the top part of this here now. All we're missing is this part here, the x plus 100. So what we need to do is just divide everything by x plus 100. So now on the right side we get 3x squared plus x plus 100 over x plus 100. And then on the left side we get similar again, x squared plus x plus 100, and then in the middle we get the original function. You always need to end with this part being f of x. So we're just going to rewrite the function out 2 plus sine squared. Now there's nothing saying you can't just write f of x in the middle. There's no reason you can't. Ooh. Okay, so now we've done that, we've got the original function. We can evaluate the limit from the right side and left side as part 2 is saying. So we're just going to do that up here. So if we do the limit as x tends to infinity of 2x squared all over x plus 100, 2x squared all over x plus 100. Now we're going to evaluate this. Now, what we're going to do is times everything by 1 over x, because that will get rid of this in the denominator. So we're going to times everything by 1 over x, which will leave us with 2x all over 1 plus 100x. Now if you take the limit as x tends to infinity, we get on the numerator infinity, and we get 1 plus 0, which can be evaluated as infinity on the left hand side. Now the right hand side is exactly the same process. We're going to do the same again as x tends to infinity of the right side, which is 3x squared all over x plus 100, and this can times again by times by 1 over x. We get 3x, exactly the same as before, 100 over x, which again leaves us with infinity over 1 plus 0, which equals infinity. Now, because the limit is infinity on both sides, we can say that the limit of f of x is also infinity. However, we basically say that if the limit of x that approaches infinity of f of x equals infinity, it does not exist, and so that's that problem done. Okay, so the third question we've got is, as the limit of x tends to infinity, just like the last question, we've got 2 minus cosine x all over x plus 3. Now obviously you can't, again, just put this in because cosine of infinity doesn't exist because it's bounded between 1 and minus 1. So that's when you know if you've got a bounded problem and you can't just plug the limit in, you need to use squeeze theorem. So like before, we're going to take this trigonometric function out. We know by now it's bounded between 1 and minus 1. However, as you can see, we've got a minus here, so we need to times this by minus 1. Now when you times a inequality, the signs flip. So what we can do is write 1, flip this, minus cosine of x, and flip this one at minus 1. I'm just going to rewrite that the other way around, basically, so we're getting similar to what we had before, of x or over 1. Okay, so now obviously we've got the plus 2 that we need to take care of, so we're just going to add 2 to each side. So in the middle we've got 2 minus cosine x, and then 3 on this side, with this being 1 on this side. So now all we're missing is the divided by x plus 3, so we can just evaluate that finally. X plus 3, so we've got 3 over x plus 3, and then 1 over x plus 3, all over the original function, which I'm just going to call f of x now. So, like before, we just take the limits of this. I'm going to do that here. So the limits of the left-hand side of x tends to infinity. We put 1 over x plus 3, and this is basically 1 over infinity plus 3, which tends towards 0. Now, same again on the right side. Limit of x as it approaches infinity of 3 over x plus 3, and like before, 3 over infinity plus 3, it tends towards 0. So now we can say that since both these limits are the same, and the tend to the same, like part 2, we can say with part 3, the limit as x approaches infinity of f of x also approaches 0. So that is that question done. Okay, so the fourth and final question here we've got is as the limit of x approaches 0 from the left hand side, and the left hand side is denoted just by the it's sort of to the power of minus, it looks like, and then the right hand side is 0 to the power of a plus. Now our f of x is x cubed all times by cosine of 2 over x. Now like before, no different, cosine of 2 over x is bound between 1 and minus 1. No matter what is in the argument for cosine, it can only ever be bound between 1 and minus 1. However, we're just missing the all times by x cubed, so we're going to write that here, x cubed. So on the right hand side, we've got x cubed, and then this is quite straightforward, this one, 2 over x, and then this one's minus cubed. So again, since we've arrived at the function itself in the middle, we know what we can evaluate now. So the limit as x approaches the left hand side of minus x cubed equal to 0, and then we need to do this part here. So as that part, as the limit of as x approaches the left hand side of 0 for the right, we've got x cubed is also equal to 0, and like any other question, since they're the same, we can say that the limit as x approaches the left hand side of 0, we can say that x cubed of cosine of 2 over x also is 0. Okay, so that's that fourth and final question done.